Hey, what's going on, guys? Mr. Flores here, and this video deals with graphing and basically working with quadratic functions, okay? A quadratic is an equation or a function that's in the form y equals ax squared plus bx plus c, right? This is also called standard form of a quadratic. There's also a vertex form, which we'll talk about at a later date. But, okay, so this is a standard form of a quadratic function, which is right here. Okay, quadratics, we've all seen them before. They're also called parabolas or parabolas, so aka parabola. Okay, and basically there's two forms. There's a parabola that opens upwards, okay, and then there's a parabola that opens downwards, aka one of them, if it was a cup, could hold water. The other one could not hold water. All right, so again, this is opening up, this is opening down. The way we can tell which way our parabola is going to open is by the value of a. So if a is greater than 0, it opens up, aka if a is positive. If a is less than 0, it's going to open downward. All right, so that's one of like the first things that we kind of talk about when we're talking about parabolas, okay? Another nice thing that they all have is they have something called a vertex. So the vertex is this point right here. So it's basically the bottom, or it's right here, or the top, okay? So this is a vertex, and this is a vertex. There's two types of vertexes. If the parabola is opening upwards, this is called a maximum. And if it's opening downward, it's called a min or a minimum, okay? So basically the vertex is the highest or lowest point on a quadratic. Okay? So a vertex is the maximum. Oop, actually I mixed these up. This is sorry about that. This one is a minimum because it's the lowest part, and this is a maximum because it's the highest part. All right. So, but again, they're both called vertexes. And when we're going to graph one of these on the next page, the first thing you always want to do is find the vertex because that's our starting point for our graph. Okay. But just a little background. The vertex is the minimum here, it's the bottom of the graph, or it's the maximum here, it's the top of the graph. Then there's another thing, which is this dotted line, okay? So if we look here, there's a red line that cuts the parabola exactly in half, okay? What that is called, it's the axis of symmetry. If we know what symmetry means, it means it's basically cutting two things perfectly in half, okay? Or it's cutting one thing into two perfect halves. So the axis of symmetry is just a vertical line that cuts our parabola into the two parts. So the equation for that is going to be x equals a number, okay? And the number that it equals is just the x value of our vertex, okay? And that should make sense because the axis of symmetry always goes through our vertex, and it's always a vertical line. And vertical lines always have the equation of x equals a number, okay? So again, this is just some quick background on quadratic functions, aka parabolas. This is standard form, y equals ax squared plus bx plus c, okay? If a, the coefficient of the x squared term, is greater than 0, you're gonna have an opening up parabola, and you're gonna have a minimum as your vertex, since it's the bottom point. Then if a is less than 0, and it's gonna be opening downwards, your vertex is gonna be the maximum, aka the highest point. Okay, and the axis of symmetry is the vertical line that goes through your vertex, which is always x equals a number. Okay, so hopefully you understood that part. Again, this is just the basics of it. What we're gonna do now is we're gonna actually be graphing one. So. Alright, so what we're going to do is we're going to go ahead and graph this quadratic function, okay? Graphing these takes a little bit of time because there's certain things you have to find, but again, it's nothing too hard. But again, it's just a couple steps. So the first thing you always want to do is you want to start off by finding the vertex, okay? Again, the vertex is the maximum or the minimum of a parabola. It's the bottom or the top, okay? So the way you find the vertex is you first need to find the x-coordinate. So the first way you do it, or the way that you do it if you're in standard form, is the x-coordinate is equal to negative b over 2a. Okay? So if we're talking about our problem, all right, this is b, this is a. So for our problem, it's going to be negative, because it's minus b over 2a, is negative 2 over 2 times a negative 1. Okay, because this is a negative 1 is the coefficient of x squared, so a is negative 1, b is 2. So we're going to simplify, and you get negative, or 2 times negative 1 is 2, is negative 2 over negative 2, which simplifies to a positive 1. Okay, so our vertex is the point x is positive 1. Okay, now we still have to find out what is the y value that goes with this vertex, okay? But as we know, the vertex, or a point on a graph, is just a solution. So if you know one of the coordinates, to find the other coordinate, you just substitute this value in for the variable. So since the x is 1, we can substitute 1 in for both the x's in our equation to find y. So now y is equal to negative 1 squared plus 2 times 1 plus 1. And then we simplify. 1 squared is 1, so it becomes negative 1 plus 2 plus 1. And this simplifies down to negative 1 plus 2 plus 1 gives us a positive 2. Okay, so our vertex is 1, 2. So I'm just going to start off with putting that on our graph. So 1, 2. That's our vertex. Okay. Now, the other thing you want to be able to find is the axis of symmetry. Okay, so if we go back and we remember what happened on the last slide in the beginning of this video, your axis of symmetry is just going to be the x value of your vertex. So it's 1, 2. Okay, so the AOS, the axis of symmetry, you have to give me the equation for it. And like we said, it's just the equation of the line that cuts our parabola in half. So ours for this one is x equals 1, because it's the x value of your vertex. Okay, so now we have vertex is 1, 2, axis of symmetry is x equals 1. The next thing we want to find is the y-intercept. Okay, where is our parabola going to cross the y-axis? Now, if we remember from Algebra 1, the way you find a y-intercept is you substitute 0 in for the x value, okay? Because we know that your y-intercept, no matter where it intercepts the y-axis, your x value is always 0, so we can get y equals plugging in 0 for x. So in this equation, it's going to be negative 0 squared, which goes to 0, plus 2 times 0 goes to 0, and we get y equals 1, okay? So our y-intercept is going to be the coordinate 0, 1. All right. So the way you find your y-intercept is you substitute 0 in for x. The nice thing about quadratics is we know that it's always going to actually become our constant term, since the x squared and the other term and the ax and bx go to 0, so you're just left with a constant. So your y-intercept is always this guy right here. All right. So that's nice to know. And the last thing we have to do to graph this is we need to get some other points. Okay. So what you want to do is put your vertex in the middle. So I'm going to put it here. Okay. What we need to find is 2 points higher than 1. So let's do 2 and 3. And then 2 points lower. So let's do 0 and negative 1. Okay. Just like the vertex, the way you find the corresponding y value is you substitute the x into the equation. So this one is y equals negative 1 squared plus 2 times negative 1 plus 1. Negative 1 squared just becomes negative 1 minus 2 plus 1 for a grand total of negative 2. So the coordinate, the y coordinate goes along with negative 1 is negative 2. Now again, let's plug 0 in for x. So now we know that this is just our y-intercept, so both those cancel and we're left with 1. So we're at negative 1, negative 2 is a point, 0, 1, 1, 2. Now we have to find x is equal to 2, so let's substitute 2 in the equation. So 2 squared is 4, times the negative 1 is negative 4, plus 4 plus 1 is just, nope, not 0. Again, that's just a positive 1 because the 4s are going to cancel. So when we're at 2, we're at positive 1, and then let's throw in a 3. So it's negative 3 squared plus 2 times 3 plus 1. 3 squared is 9, so it's negative 9 plus 6 plus 1, okay, which gives us negative 2. And now we have enough points to graph our parabola, okay? We know the vertex is the middle, so it's at 1, comma 2. And then when we're at 0, comma 1, we're going to be here. Okay, then at 2, we're going to be also at 1. Then at negative 1, we're going to be at negative 2. Then at 3, we're also going to be at negative 2. Okay, we have enough points to graph our parabola. And that's how we graph it. And it looks good, okay? Just a little quick recap. This is going to have a maximum because our parabola is opening downward, okay? We knew that it was going to open downward because our A was negative, okay? But these are the types of things you got to do when you graph a parabola or a quadratic function. You must find your vertex, find the axis of symmetry, find your y-intercept, figure out if it's going to be a max or a min, and graph it. When you make your table, always put your vertex in the middle, do 2 points less than the number, the x value, 2 points higher than the x value, and you're good to go. All right, so I'm going to graph one more. And again, we know that the vertex, okay, we know that x equals negative b over 2a. Okay, so for this case, x equals negative 8 over 2 times negative 1, which becomes negative 8 over negative 2, and a negative here. The 3 negatives make it negative 8 divided by negative 2 is positive 4, but it's going to turn out to a negative 4, okay, as the x value of our vertex. So your vertex is going to be negative 4, comma, well, something else. And like we said before, to find the y value, you just substitute that. You substitute negative 4 into our equation. So you're going to get y equals negative 4 squared minus 8x minus 13. Again, so it's negative 16. Oops. This should actually be negative 8 times negative 4 minus 13. So that becomes plus 32 minus 13. When we simplify, that becomes positive 3. Okay. So the vertex in this case is negative 4, comma 3. All right, so I'm just going to plot that on our graph. So 1, 2, 3, 4, 1, 2, 3. Okay, so that's where our vertex is going to be. Again, before we do any more graphing, we know that we're going to have a maximum because A is negative. Therefore, we know our parabola, again, is going to be opening downward. Okay. The next thing we can figure out is our axis of symmetry. Okay. Again, it's just x equals negative 4, since that's the vertical line that's cutting our parabola in half. Okay. The next thing we can get is the y-intercept. And again, we know the y-intercept is a coordinate where the x value is 0 and where it intercepts our y-axis. Like we said before, it's always going to be this constant term for parabolas. Because when you plug 0 in for here and a 0 there, they cancel and you're just left with that. So our y-intercept is 0, comma negative 13. Okay, and lastly, you must create your xy table to get your values. Again, what you do is you put the vertex in the middle, put 2 less, and then, oops, I did that backwards. We're going to put negative 4, 3, then we put 1 less, another less, 1 more, another more, okay? And now you just have to find out when you substitute negative 6 into your equation, what do you get? So y equals negative 6 squared minus 8 times negative 6 minus 13. I'm going to type that into my calculator. Exactly how it is written. Minus 8 times negative 6 minus 13. And I'm going to get a y value of negative 1. Again, to get the y value for negative 5, you just do the same thing. Substitute negative 5 in. All right, and again, I'm going to do that in my calculator. and I got a positive 2. Okay, again, to find the y for the 3, I'm going to substitute negative 3 into the equation. So let's see what we get when we do that. And I'm going to show you a little trick because I already know what it's going to come out to just by doing some of the other ones. And that's exactly what I thought. We're going to get a 2. And then last but not least, I'm going to substitute in negative 2 for x. And I'm going to get negative 1. Okay. So when I graph my parabola, again, I'm just going to plot the points. So negative 5 is at 2. Negative 6 is at negative 1. Negative 3 is at 2. Negative 2 is also at negative 1. Okay. So I'm just going to graph the parabola. And again, this right here is a maximum, which we knew was going to happen because the a was negative. Okay. Now, we know that our axis of symmetry was negative 4. Let's take a look at the points on this parabola to see if we can find a trend that's always going to work. So, for instance, if I cut this in half using our axis of symmetry, okay, which again is just the vertical line that cuts it in half, it's called the axis of symmetry because the left side is exactly symmetric with the right side. So, for instance, if we go 1 to the left of our vertex, it's at negative 1. If we go 1 to the right of our vertex, it's also, oh no, it's at positive 2. If we go 1 to the right of our vertex, it's also at positive 2. That's not a coincidence because it's symmetric. Again, if we go 2 left of our vertex, it's at negative 1. If we go 2 right of our vertex, it's at negative 1. The same trend can be seen in your table because this is our vertex. So 1 less is at 2, 1 more is at 2. 2 less is at negative 1, 2 less is at negative 1. That's the whole idea of the axis of symmetry. And that's one of the ways you can see to check and make sure that you're putting this in right. If we go back to the last example, 1 left to the vertex was at 1, 1 right of the vertex was at 1. 2 left of the vertex was at negative 2, 2 left of the vertex was at negative 2. Again, if I put a line through our vertex and you look at the table, that same identity stays true. 1 less was 1, 1 more was 1. 2 less was negative 2, 2 more was negative 2. Okay? Because the parabolas are symmetric around the axis of symmetry. So if you're graphing yours and creating your equations and this is not true, then you know that you did something wrong. Okay? Parabolas are really fun because they let us do factoring and stuff. So basically what our next video is going to be solving these, quadratic functions, which is going to dig us into a deeper realm of mathematics and factor and everything. But hopefully this video made sense. Again, when you graph quadratics, you need to first find the vertex, knowing that x is equal to negative b over 2a. And then you substitute this in to find your y value. Know the axis of symmetry is x equals your x value of your coordinate since it's a vertical line going through your vertex. The y-intercept is always your constant term. Okay? And then you must build your table, do 2 less, 2 more, substitute the x values in your equation to find the y values. All right? If you have questions, let me know. Again, this is not too crazy of stuff. It's just a lot of stuff you got to know. All right? If you have questions, let me know. Hopefully you learned some. Have a good one.